Ladies and gentlemen, good afternoon. First of all, I want to express my thankfulness and congratulations to the Sunny hold such a great events to celebrate the DNA double helix 70 years and the wonderful lectures. We really enjoyed. And second, I also want to express my thankfulness to Sunny because the Champion Lab and Peking University Biopic actually establish a bridge connection the scientist and clinical doctor to do more research for the integrated medicine, do incision medicine. And I'm so lucky because I'm a gynecologist and working in the Peking University Third Hospital, Department of OBGYN, 36 years until now. And actually, our hospital is the first IVF baby born in here. Until now, annually we do the 16,000 IVF cycle. But actually now in the whole world, the successful rate after IVF treatment only 30%. Because we have many things don't know on the human reproductive procedure. So I'm happy have a chance 12 years ago, cooperation with Fuchou Tang, with Sunny Xie, and can have a chance to explain more unknown during the human reproductive procedure. And today, because the time limited, so I just talking about the 30 years of PGT, how to searching from kids from the genome. And we all know that the body changing through the whole life. And haploid sperm and egg combine to form a diploid fertilized egg. And then the eggs grow from fetus into the adult through the mitosis. And in adulthood, the germ cell under meiosis to produce a mature haploid and productive cells and complete the whole life cycle. And however, the error can occur at any stage of DNA inheritance, including DNA replication and recombination and segregation. This error may result in chromosome number abnormality, chromosome structure abnormality, and changing in copy number and nucleic acid sequence. All of these can have significant impact on the human being. And so if genetic variation happen in the reproductive system, this variation will not only result in pathology phenotype similar to somatic variations, but also have a far-reaching impact on the offspring due to the heredity of germ cell. An error of DNA during different stage of the reproductive system can lead to the diverse phenotype and effects. So it will happen infertility and special recurrent abortion. Also now about 10% in the population. And talking back to the why IVF cycle, just 60% successful rate. Actually, more abortion, more happen to about the implantation failure and mosaicism. So the abortion and fetal malformation and also the fetal death also happen during the general population and also happen after the IVF treatment. And Next, we will list the probability error that will happen in these 3 stages respectively. And so we already know the primordial germ cells while undergoing large-scale DNA methylation and erasure during early embryo development and re-establish the DNA methylation profile during gametogenesis. And Fuchou already talking in the morning, and genetic or epigenetic abnormality during gametogenesis can lead to faulty gametes causing infertility and abnormal embryo development also. And so early embryo development is a complex and definitely regulated process that is subject to the regulation by various genetic and epigenetic factor. And after the haploid sperm and oocyte combine to form a diploid embryo, the extensive epigenetic reprogramming undergoes involving DNA methylation, histone modification, and chromatin accessibility. Then result in an embryo with any disruption in this procession can result in embryo development arrest, hereditary formal, and even imprinting disorder. And in fetal stage, adverse pregnancy has become a major challenge in reproductive health. And birth defect affect 3 to 4 points of all live births, and also per year in China about 1 million. So it's a big challenge, and also account for 20% of infant deaths, representing a significant burden on the maternal and fetal health. Genetic factors, environmental exposure, and their interaction are the major cause of fetal abnormality, with the genetic factor play a particularly significant role. And approximately 40% of congenital case can be contributed to chromosome abnormality. And in the early stage of embryo development, and the most common mistake occur in chromosome duplication and segregation. Even if the error is not corrected, the aberrant cell will keep dividing. Meanwhile, the normal cell will divide to eventually create an embryo with mixed of normal and abnormal cells, leading to a condition called mosaicism. And 2 mechanisms are responsible for mechanism during the mitosis. Chromosome not disjunction and anaphase, like chromosome no disjunction happens when sister chromatids fail to separate during mitosis and end up in the same cell, and resulting in trisomy, monosomy, duplicate the mechanism within the embryo. And how can embryos repair aneuploidy? And 2 studies in 2016 and 2020 and used reversion to induce aneuploidy and construct a mouse model of aneuploidy. Experimental analysis verified that the aneuploidy cells in embryos can be eliminated in the epiblast by apoptotic mechanism, and the viability of the embryo is positively correlated with a proportion of normal cells in embryo. And to further explore the aneuploidy of each cell in embryos, our team divided the embryo into TE and SM The part of SEM will further divided into human embryo stem cell, and we isolated and sequenced single cell from TE, SM, and SM derived HESC. In this way, we can know the concordance of karyotype of each cell in blastocyst. With sequencing 438 single cell from 39 blastocysts and find a mechanism, mosaicism as a prevalence in blastocyst. We collect TE and the corresponding SM from 12 blastocysts. Single-cell sequencing revealed that 10 of the 12 blastocysts had cells with a different karyotype in T and SEM, and we found the euploid TE may not reflect the concordance karyotype of corresponding SEM, such as embryo UM1611 shown here. We also analyzed the mosaic rate of TE and SM. We found that the mosaic rate of TE and SM has no significant difference. Mosaic embryo can be transferred or abandoned according to special condition. However, in clinical practice, it's possible for euploid detected by PGT to exhibit mosaicism, which may develop into abnormal features. And our center has anchored 2 cases related to this phenomenon. And first case is Fanconi anemia family and probond carry compound the heterozygous mutation in the Fanconi gene in PGT stage, and an euploid embryo which transfer, but subsequently its chorionic vellus show abnormal with an additional 22 chromosome. It suggests that untacted mosaic embryo may be happen. Case 2, also the similar conditions. Of course, most will produce a healthy baby, but these two let these two family unhappy and have to face the abortion. And so how to continue to do the PGT advanced screening. At first, we evaluated the fetal health really on the limited test methods such as obstetrician, ultrasound imaging test, and the sequencing event cell gene detection method. Synthesis and invasive detect location the fetal disease screening to the genetic level has advanced the time of detection and diagnosis and a long times. But just like Dennis Lu already talking, actually the patients fear about that. And so the non-invasive prenatal diagnosis, Dr. Lu's work actually is a milestone for the prenatal genetic diagnosis. And but it's still far from enough to achieve the disease screening forward to pre-conception. So until the 1990 PGT could make the screening ahead of pre-implantation and become possible. So this after this nearly 30 years, we continue to do the PGT and try to make the new trust and for the genetic disease family. And PGT is an effective technology to improve the pregnancy outcome of infertile couple or family with genetic disease. And as the development of genetic medicine and genetic test on single cell genome level has been realized. Since 2018, according to the different indication, the method for the implantation genetic diagnosis from PGD, PGS, diagnosis screening, to PGT, pre-implantation genetic test, and also can divided into three categories. PGT for aneuploidy, we call PGT-A, and PGT SR for the chromosome structure rearrangement, and also PGT-M for monogenetic defect. And the invention of PGT could date back to early 1985 when PCR came onto the scene, and the revolution for DNA analysis to target specify DNA sequence for amplification. And just 5 years later, in 2019, researchers achieved groundbreaking milestone by utilizing the PCR in the first ever case of PGT-M. This innovation approach prevented two couples with X chromosome linkage disease from transmitted this abnormality to their future generation. And clinical application of PGT is separated from biopsy techniques. There are several options for performing biopsy. Polybody could be removed respectively from the unfertilized oocyte or the zygote for biopsy. And 1 or 2 blastomere at the cleavia stage, or 5 to 10 T cells at the blastocyst stage could also be retrieved for biopsy. According to the diverse disease stage and morphology of embryo for biopsy, and several methods can be applied to remove the cell. Aspirate inside the biopsy micropipette is most widely used method applied to biopsy at all stages. And also there is other method. And as we all know, multicellular methods are extremely limited due to the insufficient of both embryonic sample and the germ cells. So we need to introduce a single cell genome sequencing into the research on the embryo and germ cells. And so we have many new methods produced by the scientists and in the world. And so the PGT technology has developed rapidly over the past 3 years because the method improve. As mentioned before, genetic screening for human embryo was first reported by Professor Hedson using PCR in 2019, and this accomplishment selected female embryo to prevention transmission of X-linked disease. And with the development of genetic amplification and sequencing technology, and a lot of PGT methods have been developed and applied in the clinic. So recent years become the focus on concern and new direction in the future. And so this is the cases for PGT-A, small chromosome segment deletion, and PGT-SR for small translocation family, and the PGT-M for the PKU family. And we have a more method to treat different unknown before cannot diagnosis or cannot treatment family. And PGT-M combined with the HLA type is a useful technique to have a healthy offspring, and cold bladder is used for the HSCT to treat affected symbol also. And this is the case after transfer, the embryo was implanted tested, and a healthy new baby was born in the September 2019, and the baby's cord-blood HSC was successfully transplanted to his affected sibling. And 4 months after transplantation, the enzyme of the probate reached the normal level. So improve the safetyness of PGT, and our advanced technique called NICS have been developed these days. And with NICS, we detect free DNA in blastocyst fluid and spent embryo culture media instead of biopsy. So there will be remain less damage to the embryos. Of course, there is still many efforts need to be made for current NICS detection. The accuracy need to be verified, and also have a way to go before clinical widely used. And compare with the traditional invasive method, which do biopsy of different stage blastocyst or embryo to germ cell, the further DNA and the novel minimal invasive approach use cell-free DNA in span embryo culture media. Therefore, it causes less and low risk to embryo. So similar to ordinary PGT, we hope non-invasive method could not only be applied in test and deployed called non-invasive PGTA, but also in single gene inherited disease, and also including the structure arrangement and structure SR. And so compared to the result, SECM and T biopsy, it was found that consistency rate of non-invasive PGTM was 57%, and for non-invasive PGT SR, it was up to 85%. And so even exact controversy, we need to quickly can use the in clinic, and source of cDNA directly related to accuracy, do more research. That's the work our team done, and we find the cfDNA in SECM from both embryo cell and maternal cell, including cumulate cell and polar body, especially the embryonic cell resource, including both SEM and the TE. And from the SECM cell resource exploration, we also discovered some maternal contamination. And we can see it also exhibit different contamination ratio according to the resource, including accumulated cell, polar body, and net maternal contamination. Not surprised, the maternal contamination affected the non-invasive PGT detection accuracy of abnormal embryos. And with increased maternal contamination, the gender disorder and false negative rate of non-invasive will increase. And series MCC, for example, once the maternal contamination exceeded to 60%, the embryo chromosome ploidy inferred by non-invasive PGTL will be not correct, and more so we can do more the research. And more than 4,000 baby, the anti-non-invasive implantation genetic test continue to do the research. And we can see this one, and cause the time limited, so I just present how to eliminate maternal contamination as ECM is still a challenge, and question also remain in other aspects. The third generation sequencing arises at the historical moment as a novel advancement of PGT and TGS as a long-read method compared to the NGS, has greatly improved the detection of complex structure variation and can be used in more situations, such as direct localization of translation breakpoint. Despite the higher accuracy of TGS, it costs a lot more at the same time, and TGS has improved the understanding of genome. So meanwhile, no single genome help many human genetic diversity. Prior research have found the metabase in SVs as polymorphic in the population. So however, in order to address the reference base, we need to shift and pan-genome reference, which is capable for tracing fusing gene completed assembled to transportable elements and has great performance in solving the problem. So LRS has been put on clinical embryo test routine for SR and for PGT-M. And here is the example. And 30 years ago, thanks to invention of PCR technique, the PGT was first applied to clinical. Until now, there is many improvement. And so on the occasion of the 70th anniversary of the DNA helix discovery, we recall the PGT history and obviously and development of PGT and genome technique was coordinatory since the advance of PGT relies on improvement of the genome sequencing. And so far, PGT has applied more than 300 monogenetic disease worldwide used, and more than thousands of babies have been born through PGT. So today, on the occasion of these three, great events, and so thank you for everybody's effort. And I believe with the cooperation of scientists all around the world, genomic technique and PGT will keep improved and bring hope to the new family. Thank you very much.
Thank you very much, Professor Qiao.